Okay, now let's just say that here x has a value of 17.2 and here x has a value of 18.6. I find that a little hard to read, but that's what it says. And I wrote it out a little bigger here. So we want to find the probability of x falling between 17.2 and 18.6. Now let's put an interpretation on that. We did a sampling. We got numbers kind of similar to these numbers. When I took a series of about 10 sips out of a bottle of orange juice, okay? So, we found, these aren't the right numbers, but we could easily have found that the mean was 16 grams and the standard deviation was 2 grams. Okay. Now, if that's the case, and I take another sip, and weigh this out, well, that one was 18 grams. Now that's to the nearest gram. We didn't weigh it to the 10th of a gram, so we don't have any good way of actually testing whether it's between these limits, but actually it is because it rounded off to 18 grams. It didn't feel like that much. I thought I'd underdone it, so I'm not very good at that, but that doesn't matter. Okay? So it just so happened that I did turn out here. Now, if my mean really is 16 with a standard deviation of 2, what were the chances that I was going to hit that range? Okay, well, the probability of hitting that range is this area. We could estimate that from the picture. Based on my picture, what does that area look like? If the area under the whole curve is 1, well, clearly this is less than 1, right? And clearly it's less than 1/2 because it's less than the area of this half under the curve. So certainly the area is less than 0.5. Now, does this region constitute more or less than half of the area to the right? In other words, if I just take this part of the curve, what's greater, the area in the purple shading or the area of the two regions in this half outside the purple shading? It looks fairly close to me, but I'd say it's a little less than half. Okay, so it's a little less than half of half. Well, half of half would be 1/4, would be 0.25 or 25%. So I'm going to estimate the area under here. I'm going to go 23%. Okay? Now, this is based on my picture of the curve and on a lot of other things, so I don't necessarily think that's going to be a great estimate, but we'll just go with that estimate and compare that with what the actual area is. Okay, now we're not going to calculate the exact actual area. You could do that using a procedure called integration with this function, and Wolfram Alpha would do that for you, and I could tell you how to do that very easily, but you can save that idea for a later time when you take calculus. Okay, so our estimate is 23%. Now, in order to put this information into what we know about the normal curve, or at least what I've told you about the normal curve, we have to figure out what z number goes with each of these, because we have to be able to put z numbers in here. We don't know how to put x's into this. We do know how to put z's into this formula. So the question becomes, what's the z value that would go, what z number would go with x equals 17.2? If this really is at 17.2 on the x scale, what is it on the z scale? And if this is 18.6 on the x scale, what is it on the z scale? So let's take a look at that relationship.